All right, so today we're going to look at some applications of sinusoidal functions, which again, sinusoidal can be sine or cosine. It doesn't matter. Either one works. And we're just going to look at the scenarios and then try to actually write some equations from what we are given. So it says the Ferris wheel on Navy Pier in Chicago has a 70-foot radius. That's key. Passengers load the Ferris wheel from a platform 10 feet above the ground. Also important. After loading the passengers, the Ferris wheel moves in a counterclockwise direction. Sydney begins a gondola at the 6 o'clock position of the Ferris wheel. The wheel takes 4 minutes to complete a revolution. Make a sketch showing Sydney's height above the ground for one complete rotation of the Ferris wheel. Find a function that models this height versus time in minutes for Sydney's ride. Okay, that's a lot of stuff to have to try to decipher here. So I think it's first helpful to look at, okay, we're dealing with a Ferris wheel. So we can start with that. What do we know about this Ferris wheel? Do we know anything? Are you getting on the Ferris wheel at ground level? Where are we getting on the Ferris wheel at? 10 feet above the ground. So from here to here is 10 feet. Right? If you've ever ridden on a Ferris wheel, you usually have to walk up the steps to get on the platform. Okay. What else do we know about the Ferris wheel? Logan, what's one other thing you know? The radius is 70 feet. So remember, radius for a circle is from the center to the outside. So from here to here is 70 feet, and from here to here is 70 feet. That's the radius. The fact that it's going counterclockwise isn't like that important. I suppose you can note that, but it's going that direction. And it takes 4 minutes to complete a revolution. So all the way around takes 4 minutes. Okay, so we need to figure out some things that are important to write this equation based on this. So first thing I want to talk about is the period. What information tells me what the period is? 4 minutes, right? This 4 minutes to complete a revolution tells you how long it takes for one complete revolution. So the period is 4 minutes. The amplitude of this circle, based on this information, remember, amplitude is the distance from your midline to your maximum. So your amplitude, and you're dealing this with a circle here. You're dealing with the value of this Ferris wheel. So your middle is right here of the circle. Right from here to here is how far? 70 feet. So your amplitude is 70 feet. But we got to think about the vertical shift a little bit, because that's a little bit trickier because of this 10 feet here. So if you can imagine starting here, you're up 10 feet from normal, but your midline, remember, is in the center. So I'm going to pause there and just try to model this a little bit before we get into all this, because sometimes it's easier to try and picture this way rather than somewhere else. Okay, so at 0 minutes, how high above the ground are you? You're 10 feet above the ground, right? Because when you're at 0 minutes, you're getting on the Ferris wheel. Are we all good with that? Okay, so we want to start our height at 10 feet. So my y value is my height. What's the x-axis going to represent? Time. Yep. Okay, so at 0 seconds or 0 minutes, you're at 10 feet above the ground. And then you are going around the circle. You're going up here. That's as high as you get, and then you come back down. So if you were already 10 feet off the ground, you add 70 feet, that puts you at 80 feet, right? Plus another 70 puts you at what? 80 plus 70 is 150. Okay, so your maximum height is 150. Are we good with that part? Okay, so basically, you're starting here. You're going up, you're up. You hit your maximum, and you're coming back down until you get to 10 feet. And then you go back up, and then you come back down. Then you go back up, and then you come back down. What was this maximum height here? What did we just say that was? 150. So we have to figure out where the midline is, and that's going to help us here. And so your midline, remember, is just halfway between your minimum value and your maximum value, which we know from 10 to 150 is 140. So your amplitude, that's why that's 70, but you got to figure out what this value is. So if you're at 10 and you have to go up 70, where does this put you at? 80. So your midline is at 80 feet. Because your distance from here to here has to be 70, and your distance from here to here has to be 70. How long did it take me to go from my 10 feet back down to 10 feet? How much time did that take? 4 minutes, so that's 4. Okay, so we just had to figure out some things from there. Do I know my vertical shift then? Where's my midline at? 80 feet. So your vertical shift, remember, is the distance that your midline has to go. So your vertical shift is 80 feet. Is it going to be easier to write a sine or a cosine function for this? Why? Gage says cosine. Yeah, it looks like a cosine graph except for it's flipped, right? Do you see that? Normally cosine starts at its maximum, now it's starting at its minimum. So it's probably easier to write cosine because then you don't have to worry about what this value is. Does that make sense? That makes it easier. You still want to, this would be 2, this would be 1, this would be 3. Still want to write your times, 1, 2, 3, 4 minutes. But your actual goal is to write the equation, and so it's going to be easier to write a cosine equation. What am I missing? Do I have a phase shift if I write a cosine equation? I don't have a phase shift, so I don't have to worry about it. However, I do have a reflection, which I'm going to write as a reflection over x. Okay, do I have enough information to write this equation? I think I do. So we've got an equation of y equals, since I'm reflecting over x, I need this number out front to be negative because I'm flipping it. My amplitude is 70, so I got to start with that. That's my a value. I'm using cosine because this is cosine's graph flipped. Do I have my b value? I don't have b yet. We should probably find b. Remember, b is found by taking 2 pi divided by, or your period equals 2 pi over b. My period is 4. I got to set that equal to 2 pi over b. If you want to, you can multiply both sides by b and then divide by 4. So you get b equals 2 pi over 4, which simplifies to pi over 2. So b is pi over 2. You still need your x. Did I shift it at all? Okay, so I don't really need those parentheses, but I already drew them in there. So pi over 2x. And then your vertical shift is 80. So this is plus 80. Okay. So that's it. Yes, Molly? Yes, this is the reflection right here. If you have a reflection over the x-axis, your amplitude is, there's going to be negative out front. Good question. Any other questions? Gage? Yep, you don't need the double parentheses on this one. I just wrote it because I'm used to doing the phase shift, but you don't necessarily need it. And you could write this as sine. You're starting, if you were to write it as your sine value, notice you're just starting at 1 minute rather than at 0 minutes. So you could have wrote it as a phase shift of 1 to the right if you wanted to, based on this. But it's easier if you don't have to worry about the phase shifts. Okay, so that's that one. Let's look at this next one. This says the number of hours of daylight measured in 1 year in Ellenville can be modeled by a sinusoidal function. During 2006, which was not a leap year, the longest day occurred on June 21st with 15.7 hours of daylight. The shortest day of the year occurred on December 21st with 8.3 hours of daylight. Write a sinusoidal equation to model the hours of daylight in Ellenville. And they tell you, thankfully, that June 21st is the 172nd day of the year and December 21st is the 355th day of the year. That's helpful. Okay, so we're modeling daylight. Over how many days? What's the first sentence say? The number of hours of daylight measured in 1 year, which is how many days? 365 days. Yep. So that's important. You got to make sure your units are consistent. So if they start in years, but then they're giving you things in days, you got to convert one to the other. It's easier to convert to days. Okay. We know on June 21st, that's the 172nd day of the year. How much daylight was on June 21st? 15.7 hours. So I'm just going to write this as an ordered pair. So on the 172nd day, I had 15.7 hours of daylight. And then on December 21st, which is the 355th day of the year, it says I had 8.3 hours of daylight. And they tell you that this is the longest day and this is the shortest day, which is helpful because that gives you your max and your min, right? Because they tell you it's the longest, that's your max. They tell you it's the shortest, that's the min. So that's important for this information. All right, so we need to try and figure some things out here. Our x value is based on days. What's our y value? Hours of daylight. In hours. You can write it like that if you want to. So you gotta kind of distinguish all that information. Okay, so I think it's sometimes helpful to maybe start with this graph here and then try to pull some information because then you know what you have and what you need. I don't necessarily know like what the shape looks like completely. I just know the max and the min. So I don't have as much information as I had on the previous example. But I do know that I'm going out to, I'm just going to put 172 here. I just like picked a spot best I could. And from 172 to 355, I know I have a max and a min. So my maximum is up here. My minimum is somewhere here. I don't know where. And at 172, I know this is 15.7 hours of daylight, and at 3:55, I know this is 8.3. Okay, so if you can imagine like your sine and cosine curve, if you were looking at this, this was your max, this was your min. So you only have half of your curve. You see that? Because you have your max, you have your min. You either need to dip down and come back up for a cosine, or you needed to go the other way in this direction. So you can like try to make your shape. Like I try to make it so that if I could make another wave, I could. But that's really what we got going on here, is this picture. And we're starting in our max here. Here's our min. We need to figure out the midline, which is halfway, because that's helpful information. This is days, this is hours. How am I going to find that? Why don't you see if you can calculate that midline? I'll give you a second to do that. Anybody get it? Does anybody know the amplitude? It's decimal. What'd you get, Tucker? 3.7. Yep, you should get 3.7. How'd you get that? Yep, you just take this divided by this, or this minus this, that gives you the total distance, and then divide it by 2, which gave you 3.7. So from here to here is 3.7, if you want to think about it that way. But if you take 15.7, subtract 3.7, or 8.3 and add 3.7, that puts you at a midline at 12. How many of you got 12 for your midline? Okay, good. Okay, so our we just found our amplitude. That's good. I'm going to write that down. Amplitude is 3.7. We need that information to write our equation. Our vertical shift, we just calculated that. The midline went up 12, so your vertical shift is 12. That's good. Do I know the period? We're modeling hours of daylight over 1 year, right? So that's 365 days. So the period is 365 days, which can help us find our b-value. So, yeah? This is only half of, from here to here is only half of your period. Is this one full rotation? No, so if you take 355 minus 172, oops, you get 183, which is half of 365 essentially, because it's an odd number of days. So this from here to here is only half of your period, and you can look at it as this is half of 365, or you can think about it as this is half of your cosine curve. That's how I look at it. So your period is 365. You got to find your b value, which is taking 365 and setting it equal to 2 pi over b. You got to do that to find your b value. Multiply both sides by b. divide by 365. I just left it as 2 pi over 365, which isn't not a very nice number, but it's fine. I got to figure out the phase shift here. If this is, first of all, do you see this as half of sine or half of cosine? Half of cosine. How come? Because it's starting at your maximum. So because you have a starting value at your max, that should tip you off that this is cosine. That's like a helpful hint. If you try to write it as sine, you can, but you just have to do a lot more calculating. So you just try to pick the easiest one if you can. Okay, so since I'm starting at my max, this is cosine. And maximums, usually your cosine starts at the max, but now we're starting at day 172. So because your max has been shifted over to 172 days, your phase shift is actually 172 to the right. Based on that. Because of this number right here. That's where your maximum was starting. Okay, so you have enough information to write the equation now. Y equals, why don't you try to write it? I'll give you a couple minutes to do that. Okay, this is what we should have gotten for this. Y equals 3.7 cosine 2 pi over 365, x minus 172 plus 12. How many of us got that? Okay, good. That is what we should have. Homework for tomorrow. I'd like you to flip to this page here. The very next page for practice problems. 4, 5, and 6A is all I need you to do. You are going to have a question like this on your CFA tomorrow. So please make sure that you are practicing these 3 problems and getting a good idea. The answer key is attached so you can kind of see how you did there.